Till now, we only modified drugs. But modification is not enough because the body has one final goal: to eliminate them. That's where we enter phase 2 of biotransformation. It's also called synthetic or conjugation reactions. Here, the drug or its phase 1 metabolite combines with an endogenous substance to become highly polar and highly ionized, so they can easily excrete it. Now, unlike phase 1, this reaction needs energy because now we are not just modifying, we are finishing the job. The most important conjugation reaction, that is glucuronide conjugation. Drugs with hydroxyl and carboxylic groups combine with glucuronic acid. For example, chloramphenicol, aspirin, phenacetin, morphine, metronidazole, etc. In this ground, there is a clinical insight. Even endogenous substances use this pathway, like bilirubin, steroid hormones, and thyroxine. Now, enterohepatic cycling. Drugs excreted in bile can be broken down in intestine. It can be reabsorbed and circulate again. As a result, prolonged action happens. For example, phenylephthalin and oral contraceptives. Next come the acetylation action. Here, drugs combine with an acetyl group using acetyl-CoA. Target groups, amino acids, and hydrazine groups. For example, sulfonamides, isoniazines, PAS, hydrolazines. Now, what is the hidden insight over here? Not everyone acetylates drugs in the same way. Slow acetylators, fast acetylators. This genetic difference affects drug response and toxicity. Now, methylation move. In methylation, drugs like amines and phenols receives a methyl group, known as methionine, and cysteine. For example, there is adrenaline, histamine, nicotinic acid. Now, next come the sulfate shift. Here, phenolic compounds and steroids are conjugated with sulfate by sulfokinases. Now, for example, there is chloramphenicol, adrenaline, and sex steroids. Now comes the glycine grouping. The drugs with carboxylic acid groups can combine with glycine. For example, salicylates. Now there is a point to remember. This is a minor pathway. Now comes the final one, the glutathione guard. This is a protective mechanism. Glutathione binds highly reactive intermediates like quinones and epoxides. For example, paracetamol. Now, in overdose or in enzyme induction, toxic enzyme intermediates increase. Glutathione gets depleted and toxic compounds bound to tissues. Result, tissue damage. Now, if we look at the bigger picture, phase 2 reactions, they don't just modify, don't just activate, they detoxify, neutralize, and eliminate. So, if phase 1 prepares the drug, phase 2 decides whether it leaves safely or cause harm. That's all for the day, people. Thank you for listening.